that is a pretty huge crater. Did you guys hear about that? It was happening. I think I can't remember. It was 50 football field, something.
20.
Alexis?
It looks small though.
It looks kind of small in this picture, but when you saw it on the video, you see that it's pretty huge, right? Charlotte?
My grandma lives over there.
Does your grandma live in Arizona? Has she ever been there?
Yeah.
Cool. Well, maybe if you go visit her sometime, you'd be able to see it. It'd probably be really cool to see. Anna? That is a very good question. She asked if are you talking about the meteorites themselves? Do they break or do they just stay there? So you can actually find meteorites sometimes, and there are people that search for meteorites because they can give a lot of information to us about space and different minerals that are in them, can tell us different things about how old they are and where they might have come from. So you can actually find pieces of them, but they do kind of break apart because they have so much force when they hit the earth. Like you don't see the big meteor here in the center anymore that was there when it hit. So they kind of break apart when they have so much force to impact the earth that way. Jeremiah?
That's like a giant skate park pool.
Kind of. All right, so we're going to do a little bit of an experiment now. Hannah, would you mind grabbing the lights or turning those lights back on for me? We're going to practice making our own craters with our own meteorites. Okay? But what we're going to try and test is figure out how the size of a meteorite might affect the size of the crater that it creates. Jesse, do you have a question?
Are the meteorites really that big, or when they hit Earth, do they explode to make it more big?
Do you mean, is the meteorite that hit in this area, was it actually that big?
Yeah.
It was not actually that big. I think they said in the video it's somewhere around 150 feet in diameter.
Yeah.
So the meteorite itself was not this large, but the impact that it has was so great that it caused a very large hole like that. Charlotte?
Since this was like lots of years ago.
Yes, it was a long time ago.
Doesn't a meteorite form in the rock?
Ah, you're talking about kind of like fossils or things like that? Yeah, so over time, Charlotte has a good point. Different rock and other things are going to pile on top of the meteorites. It's probably going to have layers on top of that. You might have talked about that with Mrs. Himshoot. Yeah, making sedimentary rock. So, all those things happen over time, yes. And that's why archaeologists and things like that can sometimes find them too. Okay, so I know that it's really fascinating and we probably have lots of questions on meteorites. And maybe we'll have some more time at the end to talk about them more. But I want to get on to our experiment so that we make sure we have time for that, okay? So, first thing, I'm going to hand you guys a sheet. And we're going to fill in some information first before we start so that we make sure that we record the right data, okay? So when I give you this sheet, go ahead and put your name on the top. And then we're going to work together to fill in a few of the parts. And then I'll have you work in groups to actually perform the experiment. I have our meteorites that we're going to use today. Okay. So we're going to use these meteorites. You'll all get a chance to test all 5 meteorites. Okay, they vary in size, but they're all shaped like a sphere. Okay. So we have a racquetball, we have a golf ball, we have a bouncy ball, which is really cool. It's Avengers. We have an orange, and we have a baseball. Okay? So we're going to work together first to find the diameter of each of these meteorites so that you guys can record that on your sheet, and then we're going to actually perform the experiment, and I'll show you guys how to do that. So how do we find the diameter of something? What is the diameter? Who can tell me? Caleb?
Centimeters, so we just need centimeters?
It is in centimeters, yeah. We're doing science, so we're going to use the metric system.
So you can use a ruler. Just like pencil.
So I have a ruler here. What do I need to do now? Do I need to wrap my ruler around my orange? Is that the diameter?
No.
What's the diameter?
You put it on it. Make it start at 0. And you go as long as it is until you see how big it is. And then once and then you find the size.
So you're measuring across the orange is what you're saying,
Yes.
right? So the diameter is from one side to the other of a spherical object. It's not, it's like if I put a line right through the middle of the orange, that would be its diameter. Okay? Charlotte, do you have something to add?
You could also use a grid with each block is a centimeter. And you could also
Say it one more
a
time.
grid.
Oh, a grid. Yeah, that would work too. So I'm going to use the ruler right now because that's what I have right here. And it's not going to be completely accurate because my orange is round. But if I hold it on here, we can kind of see, and I look straight down at the centimeters, it's about, let's see, am I on the right side even? I'm not. That's inches. Here we go. Starting at 0, I'd say my orange is about 8 centimeters in diameter. So why don't you guys record that the orange is 8 centimeters in diameter.